Welcome to Intro to SciKit-Learn. This was a workshop held January 15, 2025. So the goals of this workshop is to introduce you to SciKit-Learn, along with the data pre-processing and feature engineering steps you can do with it, and also to introduce you to common machine learning models that SciKit-Learn gives you access to. So to begin with, what is SciKit-Learn? SciKit-Learn, often abbreviated as SK-Learn, is a Python library designed for machine learning. It includes many different packages, including both regression and classification algorithms. It can also be used to process data and create features, as we can see later. And in order to follow along with this workshop, and also just to see the notebook itself, we can clone the GitHub repo here. And the folder we're concerned with is this one. It has the slides and also the notebook and also the dataset. And you'll notice the dataset is the same as the Pokemon dataset from the Intro to EDA workshop we had last quarter. So if you would like more information on that, please check it out. So in machine learning, the goal is to use information in the data to make predictions. Information you input is called features, and what is output depends on the kind of task. For classification tasks, where you want to decide if something belongs to a category, for example, if someone is male or female, or if they're a teacher or not, then those categories are called labels, and that is what is being predicted from information in the data. For regression tasks, aka you're trying to predict a number, for example, given a person's age and years of experience, predict their salary. The output is numerical. Now then, features can be either numerical or categorical. Like, for example, you're trying to build a model for predicting penguin species, which is a classic machine learning task. The features can include beak length, wing length, foot size, and also beak color and penguin feather coat color. Now, two of those are categorical and the rest are numerical. And what often happens, we'll see later, is that the categorical variables get encoded as numbers as well, because machine learning under the hood is a lot of math. And the labels you're trying to predict are the penguin species of Gentoo, Adelie, and Chinstrap. Now then, SK-Learn provides a variety of tools for pre-processing data to create features, including the aforementioned conversion of categorical features to numerical ones for the sake of processing. So we have the standard scaler, which standardizes training data around the mean standard deviation, which is helpful when your data is not all on the same scale. And then you have things like principal component analysis, PCA, which is a bit more complicated than what we're doing right now, but essentially it is dimensionality reduction. When you have data with a lot of features, you only want the most relevant ones for prediction, so you cut away the ones that aren't as impactful. And here I will show you how those work. So here we are importing SARE libraries, importing the data, first few rows of the data, and here we're going to process the data by handling the missing values by filling NA with none. For the sake of example, and also like ease of understanding, we're going to divide the data into categorical features, which are type 1, type 2, which if you look up here are things like grass, poison, and then numerical features are everything else. And for their next example, we are going to be predicting attack and also legendary status. So in machine learning, you have your X, which is your features, and then you have your targets, which are your Y's. So we'll just run this here. And so for pre-processing, we're going to use the imputer So what an imputer does is it takes missing values and fills them in with a selected value. In this case, we chose the median because the median is more resilient to outliers than, say, the mean or the mode. So we can see this here. And like I mentioned earlier, we're using the standard scaler to scale the numerical features in case like there's any weird outliers due to Pokemon being different generations or whatever. This is also just to make sure it's more consistent. And also, we also have other feature engineering tools for pre-processing, such as the one-hot encoder, which turns categorical data into binary values, i.e. male or female could have female be 0 and male be 1. Also an ordinal encoder, which converts categorical data into numerical by assigning them a number by category. For example, 1 for freshman, 2 for sophomore, etc. And then count vectorizer, TF, IDF vectorizer, which turn words into numerical data, and it's mostly used for like natural language processing, LLMs. We're not really going to be getting into these right now, but future workshops might, so keep your eyes peeled. So here we're going to use the one-hot encoder to encode categorical columns, such as type 1, type 2, into numerical form by creating binary counts for each category. So you can see the first Pokemon is not either of these, except grass. And please also note, you can combine the pre-processing steps into something called a pipeline. So, as you can see here. Yeah. And so some models you can do with SciKit-Learn. One of them is linear regression, where you fit a line of best fit through the data. So you have an X, an independent variable, and a Y, and use those to predict things. So, like for example, like here's an example of linear regression. We split the data into training and test sets. So you train the data on the training set, and you check how good it actually performs on the test set. So the test size here is 20% of the data, and you can change this if you want. And this random stage just makes sure you get the same result every time. And we're using the pipeline. We're using a pipeline to combine the pre-processing steps from earlier to run linear regression. And this is our predictions given all other features. And an evaluation method we use for linear regression in particular is mean squared error, which is the actual results minus the predicted results squared. This tells us how far we are in general because it is continuous. And this is our predictions and also our prediction line. So we can predict given actual attack. This is how often we got the true predicted attack. And another model we have is logistic regression, which models the probability of a binary outcome using a logistic function to map inputs into probabilities. Now then, this sounds pretty complicated, but basically, like say you're trying to predict if someone is a data scientist or not a data scientist. That's a binary outcome, 0 or 1. So given a bunch of other factors, sort of probability of whether it's a 0 or a 1. And so here we're going to use it to predict whether a Pokemon is legendary or not. So again, we split our data into training test sets using a different test size this time. 30%, we combine them in a pipeline, fit the pipeline, predict the data, and this is our accuracy rate. You see classification tasks using different metrics for success than not classification tasks. And you can see here we have generated a classification report. So the precision is out of the predicted true, how many were actually true. And out of predicted recall, out of all the predicted true, how many were correctly predicted. The F1 score, a weighted average of precision recall, and to support the actual number of actual instances in each class. So you can see here, precision of 69% for true means 69% of the time the model's legendary predictions were correct, and a recall of 73% for true means 73% of actual legendary Pokemon were correctly identified by the model. And then depending on what you want out of your model, you can fine-tune it so these metrics change. And here's just a better visualization of this, what we call a confusion matrix. Now then, another common model, this is also a classification model, is a decision tree. Random forest. So decision trees are kind of like choose your own adventure games. So say, for example, you want to make a sandwich. So the first question you have is, are you hungry? If yes, you go on one path. If no, you go on another. Following the yes path, you check, do you have ingredients? And if you do, you make a sandwich. If you don't make a sandwich. And so decision trees are basically like this. They take a bunch of features and make a bunch of decisions. And then depending on the outcome of those decisions, assign a label. Random forests take the average of a bunch of decision trees for more accurate predictions. And I can demonstrate it to you here. So here, again, we're splitting the data. We're creating a pipeline for a random forest classifier, having it make predictions. And here's the accuracy. And by accuracy alone, you think, this is pretty good. And then you look at the confusion matrix and this classification report and tell me, do you think this is better or worse than our logistic regression classifier? Why or why not? Why don't you think about it? And now we go on to more models. So for example, the k-nearest neighbors model labels an input based on the majority vote of k-nearest labels nearest to it. And I promise we're getting back to this in a second. These other two support vector machines, which finds the optimal hyperplane to separate classes by maximizing the margin between them, and naive Bayes, which classifies data according to Bayes' theorem, assuming all features are independent of each other, are a bit more heavy on the math to explain. So we're not going to go in depth on them. If you follow, and you can look more if you want in your own time. But if you are taking upper division data science or computer science classes, you will go in more in depth in these. Now then, to go back to k-nearest neighbors, you see this graph here. This is what k means clustering looks like. You group similar items together into k number of clusters. So as you can see, orange, purple, and green. This is from the Intro to EDA workshop, by the way, which I highly recommend you check out, especially for data hacks. And you'll notice and so what the KNN means is, for example, if you're here, you have 3 neighbors, let's say KA equals 3. 2 of your neighbors are purple and 1 is orange. So majority vote is purple. So you are also purple. And this, so we can see here, I'm splitting the data from the classifier. Don't worry too much about the code for this. I see it takes a long time. But basically, this shows you the decision boundary. If you're in the red spots, you get classified as red. If you're in the blue spots, you don't get classified as blue. As red, you get classified as blue, where red means legendary, blue does not. This yellow point is the test point, and these 3 are the nearest neighbors. So this is what we'd use to make a prediction. And based on this, we accurately predict whether or not Pokemon is legendary 94% of the time. And here's our confusion matrix, and here's our classification for it. And you can see when it comes to actually predicting true, it's kind of terrible. So, a word of caution for k-nearest neighbors. It takes into account all factors equally, which is perhaps not something you want. Maybe one of those features we use, since I used all of them, were not actually relevant, and it just kind of overfit to those. And so if you want to actually have weighted features. Perhaps another classifier like maybe decision trees or logistic regression might serve you better. Likewise, another word of caution for decision trees, they tend to really heavily overfit to the training data. So for example, we had features like type and HP, defense and special attack, and it will just like keep on making decisions on smaller subsets of data, and sometimes those are not relevant, and you can see in our trained test scores that despite all that, it was not really successful. So just something to keep in mind. So we hope that from this you got that SciKit-Learn is a powerful library for machine learning, data pre-processing, feature engineering, and all sorts of things, and that you've gained a solid foundation for your own machine learning studies and also your future classes or perhaps hackathons, and that you can have the tools needed to start learning more on your own. So yeah, and if you have any feedback, please leave it here.